In this video, we're going to have a look at proof by induction, and we're going to look at a proof by divisibility type of question. So as always, step number one is to substitute n equals 1 into the equation and show that, well, in this case, this expression is divisible by 4. So let's do that. When you put f of 1 into the equation, that becomes 5 to the power of 1 plus 8 times 1, which is just 8, plus 3. 5 plus 8 is 13. Is it? Yeah, sorry. Plus 3 is 16, which is divisible by 4 because we know that it divides by 4 to give 4. So that's perfect. Now we're going to write an inductive statement, which is saying that we're going to assume that for when n is equal to k, that this whole expression is also true. The fact that f of k equals 5 to the power of k plus 8k plus 3 is all divisible by 4. We're going to write that out and represent it as equal to 4 capital A, where A is an element of integers. That just means that A in general is an integer, and if this is the case, the fact that all of this expression is a multiple of 4, then that proves that it's divisible by 4. What we want to show is that f of k plus 1, which will get you to the expression 5 to the k plus 1 plus 8, and then in brackets you'd put k plus 1, but what you can see is that that expands out to 8k plus 8, so let's write that out. 8k plus 8, and then plus the 3, well 8 plus the 3 is equal to 11. And we want to prove that this is also divisible by 4. So let's say it's equal to 4b this time, where b is also an element of integers. Again, that just means that b is part of the set of integers. Integers can be positive, 0, or negative, by the way. So like minus 3, minus 2, positive 2, positive 3, whole numbers. In this case, we now have to use the inductive statement to prove that this is actually true. So let's write this out one more time. F of k plus 1 we've introduced as 5. By the way, sorry, I've got a new stylus, so my handwriting might not be the best. So plus 8k plus 11. How can we use this statement that we introduced earlier to show that this statement is true? Well, if we compare both statements, what we see is that there's one common term, 8k. So let's rearrange and make 8k the subject of this formula first. So in this case, 8k would be 4a, take away 5 to the power of k, take away 3. What we can now do is replace 8k with what we just introduced. So let's do that. We'll have 5 to the power of k plus 1, and then plus 4a, minus 5k, sorry, 5 to the power of k, minus 3, and then all plus 11. When you do that, minus 3 plus 11 is minus 8, sorry, positive 8. So let's actually cross that out and write plus 8. On top of that, you can factor out 5 to the power of k from these two terms. I think that's going to help, so let's do that. The reason why we're able to do that, by the way, is because 5 to the power of k plus 1 can be rewritten as 5 multiplied by 5 to the power of k. So let's do that because I think it'll help you understand more. Okay, now that these two terms have 5 to the power of k in them, we can factor that out from both of the terms, in which case we get a factor of 5 to get to this first term, and then take away that factor of 1. And then plus 4a plus 8. Everything's starting to fit together like a puzzle now because there is a way we can show that this is divisible by 4. Because 5 take away 1 is 4, so this is 4 times 5 to the power of k plus 4a plus 8. And lastly, we can just factor out 4 and say that's 5 to the power of k plus 1a plus 2. Now, no matter what value of k you put in as an integer, because, oh, one thing I didn't really write down, because we're assuming that n is a positive integer, so let's assume that k is also a positive integer, and throughout the whole experiment, everything else is a positive integer, just to make it all consistent. But, yeah, whenever k is a positive integer, we also know a is a positive integer, so everything in this expression would just be a positive integer. And then if you multiply a positive integer by 4, it'll always be divisible by 4. So we've proven it by induction. Thanks for watching. I hope the video helped, and be sure to like and subscribe if you did. And I'd post a lot more videos about proof by induction, so keep a lookout for those. Thanks for watching. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-level Furthermaths, be sure to hit my website up at www.excelineducation.co.uk.